Obviously, the more oxygen there is in the mixture, the total amount, or the more of the total pressure, will be due to just oxygen. The less oxygen there is, the less of it there will be. So that essentially is kind of common sense, okay? And that's called Dalton's law of partial pressures. So Dalton's law of partial pressures state that in a mixture of gases, the partial pressure of each individual gas is proportional to the amount of that gas in the mixture. If the amount goes up, so does its partial pressure. So simply put, let's say if we had air was a mixture of these four gases, some nitrogen gas, some oxygen gas, water vapor, so water as a gas here, and carbon dioxide. These are the four most common, by the way, in air that we breathe. Okay. If the total pressure was 100 millimeters of mercury, and if there was the same amount of each one of these gases in here, 25%, 25%, 25%, the partial pressure of each one would be the same, right? 25 millimeters of mercury here, 25 here, and whatever. If, however, we were 75% nitrogen, 20% oxygen, 3% water, and 2% carbon dioxide, now it changes, right? The partial pressure of nitrogen is now a lot more than the partial pressure of oxygen. So it's relative to how much there is. So to figure this out, really what we could do is we could look at atmospheric air or air in an alveolus, and we could ask the question, what's the percent nitrogen, what's the percent oxygen, what's the percent water, what's the percent carbon dioxide? Multiply that by the total pressure, which is 760 at sea level, and get these partial pressures for that, right? And we know that if these values change, the relative amounts of them change, the relative partial pressures will change. I don't want to go through that lesson, that's just multiplication. Okay? But we know that now we're going to define the movement of gases from an area of high partial pressure toward an area of lower partial pressure. Does that make sense? So oxygen will diffuse from an area where there's more of it, a high partial pressure of oxygen, to an area where there's less of it. So we'll just call the PO2 as a partial pressure of oxygen. Similarly, CO2 has to move from an area where there's a high partial pressure of CO2 toward an area where there's a low partial pressure of CO2. What did I just say? I said nothing more than oxygen moves from an area where it's in high concentration to an area where it's in low concentration, and the mechanism is diffusion. Now, is it simple diffusion or facilitated diffusion? So is a molecule of oxygen gas a polar molecule or a non-polar molecule? This is kind of interesting, actually. You know the way to answer the question? No. Are those covalent bonds there? Are they polar or non-polar covalent bonds? They have to be non-polar because the electronegativities are exactly the same. So oxygen gas, carbon dioxide gas, these are non-polar molecules actually. Okay. So as a result, they just pass through the phospholipid bilayer of the membrane by simple diffusion. So we don't have to worry about channels for these or anything like that. They're both non-polar. I mean, CO2 looks like this, right? It's a very linear non-polar molecule. Okay, so these gases move freely across the membrane. So all we've got to do then to understand gas exchange is to ask the question, is there a concentration gradient? If the answer is yes, then it becomes easy to predict in which direction these gases will move, right? So the concentrations are given in this diagram. They're pretty standard. This is what it would be like at rest. So just while you're sitting there, just maintaining your resting metabolic rate. These are what the partial pressures are. Let's not worry about this one right now. But if we looked at air in the alveolus, we know the total pressure is 760. Some of it's due to oxygen. How much of the 760 is due to oxygen? About 100 millimeters of mercury, give or take a little bit. How much of it's due to carbon dioxide? About 40. So that means of the 760, 620 of it is due to something else, right? And actually most of it's nitrogen. Almost all of that 620 is nitrogen.